welcome to the InfoQ podcast. I'm Daniel Bryant, News Manager at InfoQ and Product Architect at DataWire, and I recently had the pleasure of sitting down with Dave Sudia, Senior DevOps Engineer at GoSpotCheck. I met Dave at last year's KubeCon in San Diego, where he and Tony Ribb, a colleague from GoSpotCheck, presented about the challenges of migrating from Heroku towards a platform based on Kubernetes. We had a series of fascinating follow-on chats about building effective application platforms on top of cloud-native technologies, and Dave was clearly a pragmatist when it came to tech and business, but he was also a strong proponent of open standards, and I was really keen to understand more about this and dive into the details. Other topics I was keen to explore were that of build versus buy when it comes to a platform, and I also wanted to get Dave's thoughts on how we should create the developer experience and the UX of platforms, as not every engineer is comfortable writing YAML or working at the command line. Hi Dave, and welcome to the InfoQ podcast.
Hi, thanks for having me.
So I understand you started your career in teaching and then transitioned into software development and ops. Could you share some of this journey, please?
I was a teacher for about 7 years, special education, and then I made a career change into technology. Did a boot camp at a company called Galvanize, and coming out of that, my path in was I wasn't the most advanced engineer on any team, but when we learned about software testing, I went, oh, well, this is just a behavior plan for software, and I have half a PhD in writing behavior plans. And so I started my career in tech as a quality engineer, writing end-to-end tests for a retail platform, and then essentially writing a platform to run those tests per request from other teams and dynamically generate them. That company had a cloud team of 3 people and no manager who basically said, all we're going to be doing is making VPCs and security rules. You have to figure out how to deploy your own software. So I kind of raised my hand and volunteered to learn that. Did that for about 8 months, got fully into the cloud formation, troposphere, DevOps kind of world. And then I got headhunted as a DevOps engineer at GoSpotCheck. So I've been doing that for a little over 2 years. My 2-year anniversary is a couple of weeks ago. And yeah, it's a space I really enjoy. I like building systems and thinking about how they ought to be built. And from my background as a teacher, I love teaching people things and helping them advance their own careers and understanding. And so one of the big parallels for me in education to tech is, as a special education teacher, mostly my job was trying to get general education teachers to understand how to do my job, because my students were in their classrooms, and general education teachers in the United States are kind of now expected to be special ed experts and reading experts and math intervention experts and everything, right? And so my job was pushing in and helping those people, and moving into DevOps, it's the exact same thing. It's just pushing operations left onto developers and getting them to believe that they can and should be doing it, while providing the supports and systems that make it easier to do. So that's been the through line of my skill set, is getting other people to take on more work.
That's good stuff, yeah. So you and I last chatted, I think, last year at KubeCon in San Diego, and you were presenting with Tony, your colleague, about balancing power and pain, moving a startup from a PaaS to Kubernetes. I'd like to dive into a whole bunch of things there, but could you give us the kind of elevator pitch for why you and Tony put that talk together?
Yeah, there are so many talks you can go see where you are learning about tools, and there's fewer case studies of, hey, we tried to use this tool. And I think when people are talking about the tools, they intimately know them. They know the use case. Their elevator pitch is, this thing is amazing. And they are amazing tools, but there's a reality of implementation that is difficult, while also providing the benefits that these things claim to provide. Like, there are benefits, but we really wanted to kind of show a real life scenario. We tried to do this. Here's how it worked out for us, and the challenges we ran into.
So with GoSpotCheck, you started with a monolith and then moved towards microservices. Is that right?
Yeah, the company started with a Rails monolith, and they started on Heroku. So common story, right? And as we've grown, that has become more and more difficult to scale. At a certain point, we were one of Heroku's top 10 customers by revenue. And we literally just hit the edge of what they provide. I mean, they're an amazing service. We didn't move off because we were unhappy with them, or, essentially Heroku enabled us to become big enough to need to move off Heroku, right? But any given service, they will provide up to 10 dynos, servers, and we were at 10. And on their database side, they offer provisioned Postgres, and it's great until you hit use cases where their settings don't match what you need, and then there's literally nothing they can or will do. And again, that's not bad. It just didn't fit our use case, right? And so one of the reasons I was hired on to GoSpotCheck was sort of this coming knowledge, we're going to need to move off Heroku. And I had been working exclusively in AWS at that time in cloud, and had been doing that kind of work. And so part of why I was brought on was to help that transition. And it took a year and a half, but we pretty much got it done.
Would you recommend to others to start with the same position that GoSpotCheck started? Do you think start with monolith, PaaS, or what's your thoughts of starting microservice first? And some folks are starting Kubernetes first.
Yeah, that's a great question. I think things should be as simple as they can be. Here's why you make a microservice. You make a microservice because you need to scale the team or the service differently from anything else. And if you are a team of 3 people, there's no team to scale differently. And if you have a service that needs to scale separately, that's very unlikely to happen in the first couple of years of your existence unless you have some insane event. And so my advice to anyone starting is write an elegant monolith. Like the reason you end up in trouble with monoliths, and this still remains to a certain extent our difficulty, is that if you have a monolith where everything is tied up together, and for us, like our active record models are just a squid, right? And so there is a certain extent to which we are never going to break apart that particular monolith because it's just not possible at this point. But we can take little bits and pieces. We can build new systems where we could transition functionality. But on the flip side, a lot of our microservices are actually deployed as one unit. But internally, the new lingua franca at GoSpotCheck is Go. We've adopted GoKit as a framework for writing those. And Peter Bourgon, who writes GoKit, will tell you, you probably shouldn't adopt GoKit. It's for enterprise microservices, and we happen to be writing those. So we've adopted GoKit, but what that allows us to do is each deployable thing might have 10 services in it. But each of those services in the future could very easily be removed and broken out into its own repo, into its own deployable unit if we happen to need to scale it differently. So what we end up having are sort of like clusters of mini service groups that are all sharing a repo. They're all deployed together. They just happen to be very micro implementations that are sharing a space, but we could break them apart further in the future if we need to. My recommendation is start with a monolith, try to design it in a way where you have clean interfaces, you could break things apart, and then deploy it to a server. App Engine, Elastic Beanstalk, Heroku, any of those things. My favorite keynote at KubeCon last year was, when is Kubernetes going to have its Rails moment? And I think we'll get into this deeper. But Kubernetes is hard. In my talk, I kind of say, like, the advantage of Heroku is you don't need my team, right? And now we have my team. And so my team is building the Kubernetes stuff. But even now, our big goal for this year is to build a better, true platform internally. And one of the things we're relying on is a whole bunch of other people off my team, because it's a big enough project that my team is 2 people and a manager, basically, who's a part-time IC, individual contributor, and we don't even have time to do it all. So start simple.
Yeah, I think there's a whole podcast, to be honest, purely the microservice thing. But today I'm keen to pick your brains on the platform stuff because that's where I'm sort of most interested in. But yeah, that's a fascinating explanation already of the challenges of microservices and architecture in general. One of my standout phrases from your talk was you mentioned there was 2 ways to approach a scaling problem. One was to throw money at it, and the other was to stop throwing money at it. And I thought that's a great quote. How do you know when to throw money or not throw money at a problem?
No, that was not addressing scaling. That was the 2 phases in the life cycle of a startup.
Oh, startup. Oh, my bad. Okay.
GoSpotCheck grew 100% year over year for like the first 5 years of its life. So if there was a problem, we threw money at it, right? But it was not hard to raise funds. And so it's like, well, the database has run out of performance. Buy the next bigger one, right? Just tell Heroku to give us the next size. And then we hit a year where suddenly we weren't growing 100% year over year. And I think we've risen to the challenge of hitting that first plateau very well. But yeah, you hit a point where we literally were given the mandate of like, okay, it's time to move off Heroku. And then about 2 months later, there was a spending freeze. And I was kind of like, okay, well, you want me to build an entirely new parallel platform, or do you want me to, stop spending money? So one of the challenges we did have was, how do we start building this parallel platform while as much as possible, obviously we ended up spending more money, but it wasn't the same thing of just go do it. So we did have to build it in a very cost-conscious, iterative way, where we weren't just going out and making huge multi-regional DR cluster systems. And again, I think to what I just said, it's like, keep it as small as possible. We're still running zonal clusters in Google. We'll get regional soon, but regional clusters bring their own whole set of operating complexities that we're not ready to tackle yet. So yeah, it's been an interesting couple of years.
Nice. No, I mean, that's the best story of any business that is doing well. There's always struggles. Yeah, if you're not struggling, you're probably not doing well. So how come you chose Kubernetes as the platform to go, or the foundation, I guess, of your platform?
Yeah, that's a great question. And I like the word you just used because as we're talking about building a platform, I'll send you this link to put in show notes. But I literally just found a slide set yesterday, and the slides are titled Kubernetes is not your platform, it's the foundation. And so you have to build on top of it to build something pleasant and easy to use, right? And why we chose it. We were moving off of Heroku, and at the time there was us, and we actually had like a platform team. And there was a sense for us of if we're going to be making a seismic shift in our infrastructure, we ought to future proof ourselves as much as possible so that we're not doing this again soon, right? Because you have to make a huge investment when you're building your infrastructure. It is a thing that you carry with you for a long time. I mean, there were assumptions about the environment of Heroku that we had to figure out how to replicate or bring over into this world. And, we could have gone to like auto scaling groups, but then in a year or two, maybe we would have wanted to go to Kubernetes, and now you have to reinvent everything again. And the fact that we're a year and a half, 2 years in and still trying to build the platform that we're on, I think speaks to the investment that we were willing to make. Anyone in this world right now is, I think, to use a word you used a little bit ago, like on the vanguard of things. And there are tools that you wish existed that don't. One of the big lessons I had in my talk was if you can wait 6 months, do. We just are now starting to put stateful things into our cluster. We're running the Couchbase Autonomous Operator. And when one of my developers came and said, hey, I want to use Couchbase, and look, they have a thing for Kubernetes, I went, cool, cool, cool. Give me a month or two because I just went to KubeCon and I learned this thing about Valero that'll back up your clusters because I don't want to put any databases in our clusters. We can't back them up. I know how to back up a Postgres database by taking snapshots of the disk. At that time, we did not have a good solution for backing up persistent volumes because I know how to snap a Google disk. I don't know how to reattach it to the cluster from the bottom up, right? Like if you provision a persistent volume in Kubernetes, it just goes and kind of magically gets a disk for you. And then it is just a disk and you can snapshot it. But what's the mechanics for bringing it back in, right? And so every time we come to a new problem, the first thing I do is I go out and re-Google or re-DuckDuckGo right now, everything, and see what has cropped up in the last couple months that I'm missing or that I've missed or haven't seen, because the ecosystem is moving so fast, which is good, but it's also can be very overwhelming because features come out faster and you can roll them out. And to bring it back, Kubernetes has won the war around being the foundation of any future platforms. Heroku behind the scenes, I know, is moving to Kubernetes, right? Like there are all these new public platforms as a service that are running on Kubernetes. Google Cloud behind the scenes is just running on Borg, right? Which is the internal version of Kubernetes. You can look at their project structure and be like, oh, I'm in a cluster somewhere. So yeah, that was kind of our reasoning. And that leads to a whole bunch of knock-on decisions. Our platform team was looking at Elixir and Go. And man, I love Elixir as a language. I think it's super cool. And there's no gRPC library for it that's full on yet, right? Prometheus metrics weren't quite there. And so all that accompanying ecosystem of the Cloud Native Computing Foundation projects, they exist for Kubernetes and for the languages that are there and are kind of native to it. And it's more difficult for anything else, right? So when you make that commitment, I think it's becoming less of a binding agreement, right? Like there is Prometheus for Elixir now, right? And you can get more of those things. But yeah, it felt like the longest term play we could make, knowing that there was going to be a lot of difficulty up front with getting it all implemented.
You mentioned about like the CNCF or Cloud Native Computing Foundation. I remember, I think, chatting to you in your talk, you sort of pulled up the landscape and it's a bit of an eye chart, the CNCF landscape. How did you go about choosing and evaluating each bit of your tech stack?
That's a great question. I have been following the CNCF since there were 4 projects in it. And let's address that landscape. So that landscape is not only the technologies, it's every like company and value added product that's built on these technologies that's out there. And on the flip side, then also you go look at the CNCF sandbox and there's, 40 things in there or something. And I remember when it really was just like Kubernetes, Linkerd, and Prometheus, So how we chose our technologies. We picked Kubernetes. From there, the obvious choice at the time, and I think still for metrics, was Prometheus. Everything else now is being built on Prometheus metrics. And then we had kind of an easy shot in that we already used Sumo Logic for shipping our logs out from Heroku. And they jumped on this very early. And one of their teams built a FluentD adapter that you could just install as a Helm chart and it would ship your logs to Sumo. So that became an easy choice, right? I mean, FluentD was the solution for shipping your logs somewhere, and that's where we shipped our logs. So FluentD for logs, Prometheus for metrics. with the platform team, we kind of decided to make this an early commitment to, we're gonna commit to those CNCF open source based projects. Again, a lot of these were long-term good play decisions, but caused pain in the meantime, right? We could have just stuck with New Relic, which was what we were using for Heroku, or we could have moved to Datadog or some other more proprietary system. And I said this in the talk, like the way that companies are earning our dollars to provide the best value add on top of these open source technologies, because it gives us the flexibility to do what we need to do in whatever situation we find ourselves in. And as an example, right now, Sumo Logic came out with a system for receiving Prometheus metrics. And it's great, except, and we were in the beta for it, but you have to use Sumo's metrics queries. They don't quite match up with Prometheus ones or with PromQL, because like they already kind of auto quantize stuff where you have to purposefully, rate over a quantization period in PromQL. But that's fine, because while we're figuring that out, we're still just in the Grafana that we run in our cluster. So, we kind of have this flexibility to, maybe people can go in directly into the Prometheus and run queries to get specific things out, but we can run all our dashboards in Sumo Logic for quick overall visibility of all of our telemetry. So that was kind of why we made that decision. Let's stick with the open projects, because then we have hopefully the best set of options. And here's the key part: without causing developers to have to go back and completely re-instrument things. Like if we stuck with New Relic and then Sumo Logic had come out with the Prometheus metrics and we went, oh, that's really exciting. Well, now I have to go rip New Relic out of everything and re-instrument it with Prometheus. If we had picked some proprietary tracing technology instead of open tracing is great, because you use open tracing everywhere. And then in 5 lines at the beginning of your main.go, you set up, and send it to Jaeger, right? And the best part of all this in terms of its pluggability, right, is my developers are using Jaeger to send their traces. We're in an early pilot with someone to send our traces to them, where they're a value-added vendor for receiving open traces, but they're in an alpha. And so in the meantime, I deployed the open telemetry collector to receive my developers' traces and bifurcate the stream and send it to Jaeger and to this vendor. And the vendor made their thing as an open telemetry collector that receives the stuff and ships it to them. And so this like great pipeline, because the only thing that had to change for my developers to adopt a brand new alpha application was they changed the address of where to send Jaeger traces. It was a single config variable change, no code changes, right? And that's where this long-term bet has been paying off, is you invest in the open technologies. If everyone else invests in the open technologies, then you have lots of options to choose from. I don't actually want to run an Elk stack. I don't want to run my own Prometheus with long-term storage. 3 people. Don't have time for it. Happy to pay for it. But there's been some pain for us in waiting for the market to catch up to where we are and to support those open technologies.
So dialing back a little bit, like on the actual assembling the platform itself, I'm guessing you're gluing together bits and pieces. Are you using something like Terraform or CloudFormation? Are you relying YAML or Bash scripts, or how are you kind of knitting everything together?
Yeah, all of our infrastructure is created in Terraform, and that's worked out really well for us. We were in Heroku. We kind of had a presence in Amazon. We had S3 buckets. We had a couple early experiments running in Elastic Container Service there. So Terraform has been nice because it spans all these different providers, and it allows us to wrangle everything without having a whole bunch of different code bases. We're also, for databases right now, more of our microservice-y databases, not the big monolith one. We're using a provider called Avon. Everyone's making a provider plugin for Terraform. So that is definitely a core of how we do things. From there, on the developer side, we ended up working with a company called Harness. And they're not built on top of Spinnaker. It's a 100% original platform. For people who are investigating these tools and want an equivalent, it kind of takes the place of Spinnaker in the life cycle of being a continuous deployment tool that is completely oriented around building pipelines and workflows and putting things together. At the time that we were investigating, they were kind of the only people in the game. And we like them. It's working out pretty well for us. We've pushed forward their roadmap in some ways, and I think still stretch the capabilities of what that platform can do. And I think we would be stretching Spinnaker too. In terms of these things all being early days, I've gotten to use Spinnaker once in a Google learning session, like a deep dive on Istio, and something went wrong, and the error message was just plain text Java logs in my browser. Like, I'm really glad we didn't use this.
Spend the money where it adds the most value. So you invest in Harness rather than running your own pipeline in, say, Spinnaker.
Yeah, totally. And I mean, you see that, like, Pinterest at KubeCon last year did a talk where they spent the last year building an internal deployment tool that is like sugar on top of Spinnaker, that is friendlier for their developers to use. So many of these tools are written for me and they're not written for developers. And we have QA people who are familiar enough with the command line to run some Heroku commands, but that's as far as they go, right? And they need, maybe not need, but like their preference is to work in a GUI where they can go push a button. And that's fine. I've QA'd, I'm approving this, it ships, right? And so previously we had built these horrendously complicated things in Circle, and we've moved a lot of that over to Harness because it's just a more purpose-built tool. Circle is what we use for continuous integration and testing.
So how important is the notion of developer experience and things like self-service actions? You mentioned there that QA engineers like spin up services and tooling via a browser interface. Totally makes sense. I've seen a lot of developers wanting the same thing, to be honest, in the past. How have you designed those interfaces? Do engineers have to use a UI, the command line? Do they write YAML or something else?
A couple people have talked to me and asked me how we've done building a platform as a service on Kubernetes. And my response is we haven't built a platform as a service. We put together some tools, right? So the early days of this are, and kind of how we got to getting out of Heroku and onto Kubernetes was Circle remained our CI platform. We got Harness. And then my team kind of focused on, all right, let's figure out writing YAMLs, doing all the stuff. We put some examples out there of this is a good one, copy paste our work and put in your values kind of thing. And the early days, moving that initial application that was not Greenfield, that was in Heroku that we moved over, because part of this whole complicating effort was we were moving these applications over from Heroku. At the same time, we had spun up some teams that were doing completely Greenfield work that was completely Kubernetes native.
Oh, interesting. So you had two tracks almost.
Yeah, totally. We had people writing Go microservices that were being natively containerized and pushed out via to Kubernetes. And then we had Ruby Rails apps that we had to figure out how to containerize, replicate Heroku build packs, over. So we did a lot of the early work on both of those things. And the most success we've had has been when someone from my team has sat down with a developer and we've co-worked in a true, it's almost like that's what DevOps is supposed to be. Partnership, you know the app, I know the operations, let's marry these things and get the thing over, right? Or set up. And that holds true as we've advanced our conception of the platform. Early on, we just had every service was behind its own load balancer. Then we adopted Ambassador as our API gateway. And just recently, I had a team who, for the last year, have basically still been working on year-old conceptions of our infrastructure, which was still in Kubernetes, but just load balancing and everything goes public and back in instead of inside a service mesh inside behind Ambassador, right? So I wasn't just going to put that on him to migrate, but he also couldn't just put it on me because I didn't know his RPC names and, exactly what apps hooked up and talked to each other and how. So we sat down together for a couple hours and made it happen. What we're trying to do this year is build the platform as a service, right? Is to simplify things. I'm not sure what that's going to look like yet, but mainly because I am not going to be the only person working on it. I think the lesson we've learned in the last year and a half is that you can't just have a platform team that goes off and builds something. One of the reasons that our platform team is no longer a platform team, most of the people on it are still here, but they've been spread out to application development teams and feature teams. The thing that made it work for Pinterest was that Pinterest put a product manager on it. They treated it like a product. And I think that that's the tack you have to take. Even with our tiny team, we do not have a product owner. I manage our backlog very badly. But even with that, I have borrowed product owner time. I have gotten our AVP of technology in now as the guy kind of managing this product. But we made personas. We interviewed our developers internally and we kind of went, all right, there are people here who are super wonky and love to get deep in the weeds of configuration. And there are people here who just want to ship. And both of those things are completely valid. There are also, brand new developers who don't know really how any of this works. And there's QA people and their support. One of the learnings we've had over the last year is how do you support software that is continuously delivered? I think a lot of companies that are full in on continuous delivery are still very small, right? And it's really easy to ship 5 times a day when you don't have tier 1 and tier 2 support teams who need to know that something changed in case it broke. You've got all these companies who are like, oh, well, we just run all our experiments in production by canarying traffic over. It's like, well, that's great. But then you've got to let support know they might get 50 tickets because of the 50 people who get the canary version that is broken, right? And our manager of our tier 2 support team said, man, I keep Googling for how to support continuous delivery and there's nothing. And I was like, well, maybe you and I need to write that article. So we wrote a persona for them as well. And we're now trying to build this out in a way where, again, I don't have a platform team to just go build this platform. So we're trying to do it in a working group fashion where we've kind of split the software development lifecycle up into phases. The first one being local development. And one of the pieces of feedback I got from several people in our persona interviews was, well, the way you could make me most productive is to give me a 64-core laptop. My entire stack up of all these microservices to run integration tests and stuff, my fan is blowing out. Okay, well, I can't do that, but I can give it to you in the cloud. So we're seriously talking about, well, what if you just developed in the cluster? And we're looking at things like telepresence and scaffold. And everyone is kind of like, but how could you do that? And I'm like, well, scaffold will hot reload your code right into the cluster. And they went, oh, well, that's sexy. So these working groups have representation from someone who just wants to ship, someone who's super wonky, someone who's brand new, a QA person. We're trying to get this cross section of the company and the engineering org, at least, into these things. As we get further towards monitoring and observability and shipping it the second time, we'll bring in support people and that kind of thing. But then the work also doesn't rest on me or my team, right? Like, we're not having to build this whole thing. We're not the arbiters of truth or what's the best thing. What our role is turning out to be is more, hey, did you know that there's a tool that'll let you hot reload your code right into the cluster, right? And just kind of setting people loose. I'm the encyclopedia. I get all the newsletters. I keep up on all the news. I'm regularly searching for new things. And then I'm kind of feeding that out to, all right, well, here's the 4 or 5 options that I'm aware of that could fill that gap. Go figure out which one looks good, right? And then from there, I think we'll discover that, oh, well, we need our own cloud native build packs. The existing one isn't quite right. And then we'll write some stories, write a build pack that fits our Ruby Rails applications. And then it will be one of our senior principal engineers who's super wonky and config oriented can go write it. And then everyone can use it. What we found, having real greenfield processes or really open processes for all these teams, was we wrote those templates. Great. We said, here's our example. And you'd have a senior engineer on some team come in and go like, well, I like 97% of that, but not these 5 pieces. Right. And then the next team would come in and the same thing would happen. And I don't think that was bad. I think that what we ended up coming to was agreement across the engineering org. Like, we need to start consolidating and standardizing things. We need to have one way of writing a Go service because we have people transferring teams and they all need to re-interact. At one point, the whole promise of gRPC is that you've got this one canonical set of contracts that everyone can pull in as a package and talk to everyone else's service internally. And we had 3 different repos following 3 different conventions. And so again, like, I think from an early experimentation standpoint, that's fine. We got to the things that we like, and now we're kind of reconvening and landing on this process of like, all right, we're going to go through this working group process. Whatever that generates this is the way, right? And it's the canonical way of doing things. If you want to do something outside the box, that's great. You should go do it. But before it goes to production, you need to have worked with other teams to bring it into the box. You want to go write functions? Cool. We need to have the canonical, documented, standardized way of doing functions by the time you go to production. And then that's the way everyone will do it. Right. And so I have no idea if that's going to work or not. Let's get back together in a year and do this podcast.
Yeah, you're right. Yeah, sounds great.
And I'll tell you. But we're trying to find that balance of standardizing across an engineering organization that is now scaled to about 50 people. And we can't just have people going off into the Wild West while still allowing a bit of Wild West.
I want to finish today with the final question of, what's your one bit of focused advice for someone starting out on the journey you've been on the last 18 months or so? If someone listens to the podcast and goes, I can totally empathize here with what Dave's saying. We're starting this journey. We're in a smallish company, maybe an enterprise type company. What's the one thing they should really think or do now?
I can shrink it down to 2 things that are very closely related because they're opposites. The first one is, I think we're at a point now where you can be pretty purposeful about what you're going to build. When we started, it was just Kubernetes, right? Like, we spun up a cluster. There were a couple tools to put in there, but other than that, you were just writing YAMLs. And there are so many tools now. You can go out and find the one that looks like it's going to work best for your team. And I think you can build a bit more of a platform from the get-go. If you're jumping into Kubernetes, there's just options now and things are a bit more polished. The flip side of that is always be ready for change, because this ecosystem is moving so fast that you are absolutely just going to get overwhelmed with the amount of information coming in. And so I think the reason to be purposeful is then you can discard what is superfluous to what you're trying to build. And I think to put it even more succinctly, like, be purposeful so you can discard what's superfluous to what you're trying to build. To go all the way back to the beginning of this discussion, keep things as simple as possible. There's a sexy new tool coming out literally every couple days for this environment, and you don't need most of them. You need what will get your application to production and what will allow you to make sure it's still running. And that's what you should be trying to limit yourself to.
Super. Well, I've really enjoyed the chat today, Dave. Thanks so much for your time.
Yeah, thank you.